Trace minerals are a key component in many biochemical processes in the animal. Zinc, for example, is a cofactor in over 300 enzymes, which are particularly important in both the immune system and reproductive system. In the market today, there's really three types of minerals. There's inorganic minerals, which are like sulfates, oxides. Then there's the organic trace minerals, where they take an organic molecule and bind it to the metal. And then there's the Zinpro performance minerals. In this complex, we get a very water-soluble complex, which is stable, survives the low pH of the stomach. It's absorbed uniquely through the amino acid transporters. We get into circulation, and then once we're in circulation, we're metabolized differently. And all of this leads to better animal performance. This is very important because of inorganic minerals can't meet all the needs of the animals today. And so by utilizing the amino acid pathway and by its unique metabolism, we can increase the animal performance. The trace minerals really utilize two classes of transporters. They use the inorganic transporters, of which there's a whole family of those. And then the Zinpro performance minerals utilize the amino acid transporters. But really all the other organic trace minerals need to utilize the inorganic transporters. So antagonists will actually remove the mineral from the circulation. It'll bond the mineral, and then that bonded mineral will no longer be absorbed and will be excreted in the feces. That's one type of antagonism. The other type of antagonism actually blocks the transporters, the inorganic transporters, and prevents the mineral from being taken up into the enterocyte. The benefit of the amino acid transporter is it gives a unique way to deliver the mineral to the animal. So we're not regulated the same way as the inorganic transporters. We're not affected by antagonists. So we go uptake and absorption into the circulation, and then once we're absorbed, we're actually in circulation in a different form as well. Zinpro performance minerals are utilizing the amino acid transporters to deliver the metal. And there's a whole family of amino acid transporters, and we're learning more and more each day of how important that is. And there's cationic, anionic, hydrophobic, hydrophilic. Amino acids are all the same except for their side chain. And it's the recognition of this side chain that allows bonding to these transporters. And the mineral doesn't affect that bonding. So we're going in through these amino acid transporters. There are still differences. The inorganic minerals need to go through the inorganic transporters. Now, the organic trace minerals have to find a way in. And this is where you really see a big difference in the organic classes. So Zinpro performance minerals we know go through the amino acid transporters. But most of the other minerals dissociate and still utilize that inorganic transporter. If it dissociates before it's absorbed, then you're nothing more than an inorganic mineral. When you have that metal bonded to that organic ligand, when that dissociates because of the low pH of the stomach, now you just have inorganic mineral. And that's all you're providing to the animal. So you paid for this organic complex, but you only ended up with the inorganic mineral. Each amino acid, they only differ in their side chain. So like methionine has a certain side chain, and alanine has a methyl group, for example. And so that bonding of that side chain in the receptor site of the transporter is what allows them to bond and then be transported into the enterocyte. Then there's amino acid transporters that can transport it into the circulation from the enterocyte. Glycine is not a very good choice to deliver the mineral. It is, chemically, it forms a nice complex and it's very soluble, but when it comes to utilizing these amino acid transporters, it's the only achiral amino acid, which means it has no side chain. And now that's what's utilized for recognition by these transporters. So it has poor absorption through the transporters. Therefore, when the metal's bonded, you're not getting much metal taken up by the enterocytes. Zinpro performance minerals are metabolized differently. We have many studies that we've done to show that their urinary excretion, which means it's post-absorption, it had to get through the circulation to get to the kidneys, is at a much slower rate than other forms of minerals. So we're available in circulation longer to be delivered to the cells and tissues that need these minerals. When they're looking to decide what trace minerals to use, they should really focus on cost and value. And so to do that, you need to use some inorganics, because inorganics are utilized by the animals, but as we mentioned earlier, you don't get enough through just inorganic. And you want to use that to as much as the animal's ability to use it. Then when it comes to organics, you really should use Zinpro performance minerals, because when we've analyzed all of the other organic choices, either they dissociate in the stomach acid to become inorganic, or they're not absorbed well, both of which are critical to deliver the mineral to the animal.